Hi everyone, welcome to this presentation. I'm Vincent Esteve, Business Development Manager with ECM USA, and today we're going to talk about automation and robotics and how you can improve process stability and repeatability in heat treatment using all those tools that robots, automation, and 3D that we've been developing for the past 20 years. So for the past 20 years, automation and robotics have become more and more standard in all kinds of industry. However, heat treatment has been very manual and labor task-oriented industry. So today, in most of the plant, heat treatment is still done, I would say, manually. So here I want to show you different ways to not do it manually anymore and improve reliability and a lot of heat treatment, consistency, and a lot of good stuff for your heat treat. So first of all, we're going to start with the loading and loading. It's the first and last operation that you do in heat treat. So here on that slide, you can see on the north hand the inbound arriving of parts, and then you see a couple of robots in front. So potentially you could present parts, and then we can install a couple of robots to load on a heat treat fixture tray. Then it's taking on 1,000. You see on rails, it's a mobile cart that's going to take a full prepper load and then heat treat that load through hardening, carburizing, temper, cryo, all of that good stuff. So you can see we can settle a loading and loading unit that's going to pick it up the part and putting on the tray. On the right, it's grippers. Many different grippers can be designed for your parts. So it's not a limitation. Like you can have different part, and actually the robot can switch through grippers. So it's a first approach to do unloading and loading of the parts on your tray for your heat treat. So they can be placed at the same spot all the time, not having fingerprints and all of that. As you can see, it's a loading area on the north hand. That's where usually we set up a heat treat facility. Then here it's another approach. So I wanted to talk to you about AGV, automated guided vehicle. So on the left hand, you see part arriving before machining. They can be machined and then load one by one with the robot on a load, and that load can be already on an AGV. In red, you can see two light curtains. And then the AGV can go by himself to your furnace and load and unload your furnace just by load and unload the load, by himself for the furnace. So it's another option. It's getting there for load up to I would say 50 kilo to about 1,000 kilo, which would be around 100 pound to about 2,000, 2,200 pound. So now all those options are available in the market for loading and unloading. So again, loading and loading with robot guarantee you a better repeatability. It removes the human error factor of not loading a part, missing a part, putting dirty hands on parts, and having a lack of consistency of treatment. And also you get a more predictable takt time and throughput through your system. You know in an hour how many parts going to get in and how many parts going to get out with more accuracy, I would say. So now I want to speak more about process control. So loading and loading, it's a good start, but then how we can go to the next step to get more control on your heat treat. So first of all, everything starts with the base tray. So you're going to load the part on the base tray. What we've been doing for the past 15 years, is we put a binary code on the base tray. So your base tray has a hole and multiple hole that's linked to your recipe. So then the base tray can carry your recipe. So now you don't have to input your recipe anymore. The automatic detection of your base tray would say, I know the parts on that base tray are pinion, shaft, so I know the recipe for those parts is an hour of hardening, then quenching, then cryo, then washing. So you can link those two together through the base tray. Then we move it on one step. So like, what are the data you want to need right away without waiting for your lab to give you the data? So for carburizing, a big one is carbon pickup. We say, do I have carbon in my part? So it's the way to guarantee the treatment went well. So what we can do, we can put a sample or real part from your load. We can pick it up, weigh it before heat treat, weigh it after the whole heat treat, and have the difference of weight inside an automatic report or analysis at the end that will be linked to your load. So you take the load, the weight of the part of the sample before, you take it after, and the difference in milligram would be your added carbon for carburizing. So here I show you an example that we realized. You have the inbound part on the left. So your parts arriving in totes, in bulk, in whatever, in the example it's in totes, but you can be bulk, you can be whatever you want. So the robot pick up one part or the sample and place it on the scale in the middle for weight before heat treat. Then the robot on the right, after everything heat treat, will put it back on the same scale of that same part or same sample and say, here's my new weight. And then you have the difference, which is your carbon pickup. Then dimensional analysis, distortion. Distortion's been the main topic of the past 10 years of heat treat. Like, are we or not in spec? Do we need to straighten our part? Do we need to work on the run out or not? So usually you have to take the part off the line and do it and measure an analysis and put it back on the line and say, oh, my parts are good, I'm not good, I need to do some more machining or not. So what we do here, same thing, but in the line, we take one part and we put it in front of all the parts of your load. We put them in front of a camera, a 3D vision camera, and then right away in a few seconds you can measure your flatness, your diameter, your out round. So all those measurements can be done again before and after heat treat. So you can see here on the left, so imagining you take the part from the scale, you put it on the table on the left, they're going to measure your part before heat treat, and then you put it at after heat treat on your table on the right, and then same, you do the difference before and after, and you have your variation of diameter, run out, and all those good stuff. And furthermore, as you can see just below the table out, we have, like, for example, a shot pinning place, so you know that the part is good to go or the part is not good, so you don't have actually to shot pin a bad part. So you're saving time, you're saving tooling lifetime, you're saving a lot of time and money. And then another good point for any heat treat is hardness. Surface hardness is usually what you want to know on your parts. So here again, we do the same thing. We can take either a sample or a part and grab it, put it on a hardness tester, and then we can apply a specific force, depending if you measure in HV, HRC, or Brenner, and integrate the result in your report. So after heat treat, from your vision table, you can place your parts in the center on your hardness tester, sorry, and then you do like one indent or multiple indent for a measurement, and then it gives you the hardness, and that hardness can be inside your report. So all of that is fully transparent because it's inside your production facility. So it gives a lot of free time, for your lab to process other parts and do other things. So here you have a full view of the whole system with the inbound, the outbound, the hardness, the scale. So this is a whole setup already installed in place at a customer in a full automated line. And for a better view, we also did a 3D for that customer. So it's something now also widely available. We can do 3D of a full production center with a robot, so you can visualize actually your production. And then, as I just said before, what you want at the end is an automated report. So every load will have a report with it saying it's in spec, not in spec, with the green and red color for a very fast reading. And you know, do I have the right carbon pickup, do I have the right hardness, do I have the right case depth, and all of the good stuff. So then you don't have to wait for the lab to know if you have a good part or a bad part. So here is a quick example of report. So you have the full recipe, you have pre-data on the load, you have your hardness specification, and you see red, green. You see, for example, some parts were not in spec, other parts were in spec, and you can add some comments too. So here is an automated generated report, but it's fully like customizable. So if you want to put more or less data, it's fully up to you. So now I'm going to play a little video that's going to show you what kind of automation in real time we can have.
So here's how it goes.
Thanks for listening to my presentation today. Please don't forget to stop in the exhibit hall and look for the ECM USA booth. Myself, Dennis, Vincent, the whole team is available to answer any question you might have regarding heat-treat or automation or robot. It would be a pleasure to have you. You can even get more info on our website at www.ecmusa.com. We all available to answer any question. What I presented today was automation, robot, or heat-treat. It doesn't necessarily be ECM USA or ECM equipment. Everything can be integrated, automated. If you want more process control or more repeatability, please stop by our booth and we'll see what we can do to help. Thank you.